Okay, so when we use the word PR, it means pull request. So this is very common term. We use this term all the time. So when I said we, it doesn't just mean like super type, but generally when you go out there in the working world, every time you want to contribute to a project, your team leader is going to say, hey, can you send in a PR? So can you send in a PR basically asks you to send in a pull request. And I'll talk about the flow a little bit later about what exactly is a pull request doing. But just understand that every time I said, hey, how's your PR? What I'm asking is a pull request. So pull request is a way for you to contribute to projects, to open source projects, to closed source projects, but for you to actually write code and have that code implemented in the code base, right? So this is how it looks like. If I go into the email network, just to find something that you guys are familiar with, and this is the repository. If I go into the pull request tab, you see that there are 11 closed tabs. So there are 1 open. So every time you send a pull request, it's going to appear in here as a new open pull request. And then if we merge the pull request, so then another terminology you hear is somebody have to do a review and somebody will have to do a merge. So again, these are all very common terminologies. So just right now you may not have any kind of hands-on experience, but at least get a conceptual understanding of what it means when somebody said, hey, your team leader is going to do a review. Okay. So when you send in a pull request, now luckily for us we have 1 open, so I'm going to just use that one. So luckily for us, when you write a pull request, when you send in a pull request, you typically leave a simple comment. You say, okay, what am I doing with this? Like, what are you trying to change with this pull request? Because a pull request basically changed the code base in some way. Maybe you added new images, maybe you added some new features, maybe you try to fix some bugs and stuff. So here is a good opportunity to write, okay, I'm fixing issue number 1 and issue number 4. So in all the issues that you write, you can actually use the pound sign. If you write a pound sign, you can see that there are issues, and you can just write 14 instead of writing out the whole thing. So a good pull request would be something like that. Fixing number 14 and attempt to fix number 4, something like that, right? So you would use this pound sign, and when you do it in code, this is the same thing. So you would have something like git status, and let's say you do a get it, then you do a git commit, modify config file, okay, and then we say git. Now this git commit here is where you would try and write something like, to fix like this. Now you will say that, hey, this doesn't make sense, but it will make sense because when it comes into GitHub, when this number 14 push into GitHub, remember how I showed you that it has that completion here? So this will then turn this into a link, and I can click onto that and then see, this guy actually fixed this issue, number 14. Do you know what I mean? So yeah, so use that in your command. So when you do a command like git commit, this -m stands for command. Is this workflow at least somewhat clear or somewhat familiar, or do you want me to elaborate more?
I have seen it on YouTube actually in my case, so
Okay.
I think I'm going to study it more. But
Okay.
so far it's quite clear.
Okay, Hiti, what about you?
Yeah, it's clear. I've used this before. Yeah.
Right. So once you've done that and you submit a pull request, you do a git push, and then you will go to the main repository and you say, okay, I'm gonna now submit a pull request. So when you submit a pull request, 2 things needs to happen. The first thing is there is an automated check. Now this automated check basically is completely automated, so no one is gonna actually even have to go in here and do any of this. So let me show you what happens in the email network itself, and I'll talk about it more generally later, but right now, specifically to this case, if you go into our code, what does it say? It says that we are going to support anyone who want to use the package, they can go ahead and do that, but we ask them to use Python 3.7 and above, right? We say you need to use 3.7 and above because we take advantage of some of these features in 3.7. So if you use 3.6, you're not going to be able to use data classes, but if you look at our code, we use a lot of data classes in the object creation. So we say that if you're using 3.7 and above, we will support the package should work, right? But now, how do we know that? How do we make some sort of guarantee? How do we have some sort of guarantee that this is always going to be true? So in a way, if there is a 3-person, Adam, Eve, and Johnny, Adam, Eve, and Johnny wants to support, they each use Adam used 3.7, Eve used 3.8, and Johnny used 3.9. how do you know that your package would always work regardless of whether they're using 3.7, 3.1, 3.7.2, 3.6, 3.8.1, 3.8.2? How do you know that? So it's going to be very tedious, right? If we have to hire a team of people to test that on each different version of 3.7 above, right? It's going to be tedious. It's going to be a lot of work. So the way we counter that is we created a GitHub action workflow. This is something that you haven't really learned about yet, but you will after you've done this. If you're interested in this, I can teach you more about that. But just to show you how it looks like first, then I'll talk about how to implement that. And you don't have to learn about all this, just understand it on a conceptual level, because in time you'll learn about that. Now you see that when you submit a pull request, before a human even gets in there and take a look at your code, there is this automated checks that starts to, it kicks off a series of checks. So first check it does is that it says, okay, I'm going to try and run Python on a Ubuntu, which is a Linux machine. I'm currently on a Linux machine, so I'm going to run on a Linux machine 3.7, and I'm going to see whether or not it works even. Does it even build? Okay, so you can look at the details. It says, okay, 3.7, I'm going to first get a Linux, install Python 3, install dependencies, test it, complete that. If you go through all of this without any incidents, if all of this is successful, then it jumps to the next step, the next job. The next job will be now try the same thing except with Python 3.8 and then 3.9. And then it's going to try Mac OS 3.7, then Mac OS 3.8, and then Mac OS 3.9, and then it's going to try and do it with Windows. You see how much time it saves us? Just not having to do this tedious, like manually getting nine different jobs, manually testing it one after the other. We could just set up a simple automated test, and it would just go ahead and just run through all of this. If your app or your package works on all of them, it adds a green check marks to it. So I'll show you some examples of that. For example, this check mark says that 12 out of 12 checks are okay. If I show you the other ones, sometimes you don't always get that. Some of them I think I probably deleted that already. So if you don't get a green check mark, it means that you didn't pass the test. So yeah, it means you didn't pass the test. So that is kind of that is kind of what happens first when you send in a PR. When you send in a PR, it needs to check. It needs to run through all of the checks. If this doesn't even pass, you don't even get a green check, then nobody needs to waste the time to go and review your pull request. Okay, so when all of this is passed, then what happens is one of your team leader, your superior. Usually, when you work in an engineering team, there are people who are in charge. They are the collaborators of this project. They are the one that can merge this in. So to merge this in, they will go ahead and they will do a review, and they can do the reviews directly from here. They can do it directly from when you send in a PR. So for me, I've already done the review, so I don't really have that option now, but I could show you what happens when I click on the false change. And you can also do it from here. So there is this feature. Actually, all of this, by the way, is public. This is a public repository. So when I'm doing this from my screen, if you really want to get a sense of, get more familiarity, you can just go ahead and punch this into your search bar. And you should be able to get exactly the same view because this is a public repo, it's not private or anything like that. So once you're in false change, you see all this. I think the difference is that you probably won't get to see the review changes and stuff because you're not collaborating yet, but the rest is the same. So if you look at the pull request, you see the open, you see the close, all of that. So once you're in here, this is how we actually do the pull review. So this is what I did for Gil last time, and this is a very common process. This is a very common process, no matter where you work, what kind of jobs you work. As long as you're in an engineering job, you need to get familiar with that. And at some point, you are gonna be the one doing the code review for the junior guys, the newer guys coming in. You are gonna be the one giving them this kind of feedback. So I can now start to write my comments and write my review. So in the past, what happens is that I generally give a comment as a whole, but now because GitHub updated the UI and stuff, so there's actually better ways to do that. You can, for example, click on this one and you can ask a question here. You can say, hey, why is this needed? Why is plot.figure needed here? Because it doesn't seem to change any functionality. So I can say, why is this needed? When it doesn't seem to change any functionality. So I can do that. And you can preview your command and you can see, okay, why is plot figure? And you can say, add a single comment. Okay, so you can start a review, you can add a single comment, you can do all of this. I'm gonna not do that because I already leave all this comment for him. But this allow the user, so in this case Gil is the one who submitted the PR, he's going to receive that and he's going to see, okay, well, there is a question, how can he answer that, how can he address that. So for example, this is also a good time to look at it. For example, self.assert instance, this is not very efficient because there is the whole thing here could have been written differently. So this could be written, could be rewritten, could be rewritten as self, or actually assert this instance is fine. Yeah, this is fine. But
because he's checking whether it's a string or not, right?
Yeah, whether it's a string or not.
Yeah.
So I think this was after the last review. So the last review he did something like this. He said self assert true, and he said whether or not this would be is instance of mail.recipients, and he said whether this is a instance of the
String.
String. So you don't have to do that. You can just say self assert is instance instead of having to do that. But here, I mean, apparently this is already in there, so it's good. And this is a bunch of things here that you can take a look at, but probably a few things here. This is another instance of that. So this is also another case of not better. How would you do this? How would you do this? Like there is a better way to write this instead of self assert true is instance. You could have done self.assert is instance, and you can just do self.headers, and you can say header counter. That's it. Did not have to do the true is instance thing. Okay. Rifa, if this looks very daunting and stuff, it's because they have spent some time learning about tests and stuff. So this is how we write tests. Writing tests is a way to check that the code would always work, and you don't have to manually test it in the lab and stuff. And in machine learning context, in the data science, in the machine learning context, there's also ways to write tests. For example, you want to check an R square. You guys learn about the R square?
Yeah.
You know what the R square is?
It's the adjusted, right?
Adjusted R square and normal R square, right? Multiple R square,
Yeah.
adjusted R square.
Yeah.
Now usually you can do this. You can do something like self assert true. You can say something like assert true. You can always say that the R square should be this figure. It should be below assert between. It should be between 0 and 1, right?
Yeah.
Because that is what we understand from R square. So you want to make sure that your machine learning model is properly written. It follows some sort of rule. It follows some sort of logic, and that it's bounded and some sort of constraint and assertions. You can do that. So it's not just used for engineering. You can write very good assertions and stuff like that just to test your machine learning model before you deploy them. Because if your machine learning model comes out and your R square is above 1, well, it doesn't make sense. If it's a negative value, it doesn't make sense. So you know that, well, if it even breaks here, if it doesn't pass the test here, you don't even want this to go into deployment or production, because you're going to break somebody's system, or your model is just going to be completely unusable, right? So you can write that kind of good assertion, and so think about that in that context as well. You can apply that to a data science context, to a machine learning context. This is kind of a sanity check in a way. So same thing here. You can make the same comments here about can simplify this. And here is another one. You can ask the question of like, why do we import more? Why do we import? Because why do I make that comment? Because if you look into this file, test_summary.py, this is the file that he's writing. You will, if you pay attention, there's no reason to be importing mock. It wasn't used anyway. You see that? So then I can ask a question of like, why is mock being imported? Because it's not used anywhere in this file, in test summary. Right. So there's another way you would you do. But this is all usually a human process. Somebody who is senior at this point, somebody on the team is going to do your code review for you. But in the future, you're going to be the one doing self review. So code review for other people. So you want to make sure that you at least conceptually understand this here. I know the syntax looks a bit daunting, especially maybe Rifa. You may not have seen all of this. It looks very complicated right now, but it really isn't. It's really just like trying to make sure that there's enough sanity check to make sure your project is good. And this is another kind of instance where this is not going to be useful. So can you tell me why this is not useful?
Because it can just be self is instance of domain summary string, right?
Right. So let's say I do that. Let's say I do a self assert instance and I change that and I make it self
domain
summary. Okay, what? And I will still say that this is still not helpful. Why is this still not helpful?
Because it's already going to be a string, right? So why are we adding a string function on it?
Yeah, Rayford, why do you think this is not helpful?
I still don't know them.
Okay, the reason for why this is not helpful is that doing something like x dot string is exactly the same as doing something like this string x. It's exactly the same. There is no difference. So here you're trying to check that this will leads to a string. Just like this will lead to a integer. It's completely meaningless. Completely meaningless meaning if you try and check for something like this or you assert true,
it will always be true.
Yes, it's not meaningful. There is no point in doing this. If I say integer and I change this to 3 and I say check that this is an integer, this has no meaning at all because this doesn't even tell me whether the package is running. This doesn't tell me whether my functionality is working. You know what I mean? Yeah. So this is not a helpful. Just because it has a underscore dunder, this is called a dunder. Dunder means double underscore. So you'll hear a term called dunder. That's double underscore. It doesn't change anything. So just to give you a sense of that, right? Let me open up. I think most of you are familiar with R as well. So let me use R to explain that. If I go in there and I said something like 1 plus 1, the answer is 2, right? But it turns out what I can do is I can do something like this. You probably would never see this, but you could do something like this. And these two arguments, I can do 1 and 3. And it gives me 4. So this is exactly the same as this. You know what I mean? So just because it has a fancy way of a very convoluted way of doing a function, it doesn't mean that it's different. So when I do something like, what is it, summary, and I do something like string, this is exactly the same as this. So this is just a calling something of an internal function. There's no really a private function in the concept of Python unless you're doing C programming or C++. But let's not talk about that right now. But really, what you're doing is this. This is just a human interface. This is a nice interface. This is really just the implemented model. So same thing in here. I don't have clear words here, but okay. So same thing in here. When you see something like this, it's actually the same as 1 plus 3. It's just different ways of calling it. So and here you can also change that. So you can also change this plus, but let's not worry about that right now. So in here, this is not a useful assertion. It does nothing to to test whether your functionalities are working or not. Testing this is useful. For example, testing that this is a counter, this is useful. Why? Because if it's not a counter, some of this stuff is going to break because they expect a counter and they work on the counter. But testing whether it's a string or not has no real value. And so on and so forth. This is the same thing here. Another one in test summary here down at the bottom. This is the same idea here. No value. So kind of what you need to know is that how a human reviewer is going to see from my point of view, from our lens, from my point of view. So that would help you be more conscious about how you commit your code. Understand that the first few commits you make, right, you are probably going to get like, I don't want to say criticism because it's not really criticism, but you're going to get like feedback like that. So what I want you to know is that it's very normal. All your seniors have gone through this process, exactly the same process. All your seniors, people who are reviewing your code, have gone through this process with me as well. So don't take it as a form of criticism. Don't take it as a form of like, I feel so, I feel so like, I feel so silly looking silly in front of people and stuff. Don't feel like that. It's everyone gone through the same process. This is the only way you improve. Right, so when you submit your code and stuff, there are gonna be folks reading your code and stuff, and if you're not familiar with that process, and that's gonna be a bit scary. You're gonna feel like somebody's gonna scrutinize my code. So don't feel that way. That's the first thing I want to say. Like, don't feel that way. It's really everyone is just trying to help, and you shouldn't have to feel shy because it is the first time you're doing it, and people are gonna look at your code and stuff. Don't feel that way, right? Maybe up to this point, do you have any questions before I talk about the coverage?
Not from my side. I'm clear.
Okay. Rifa, do you have any questions?
I'm still processing, but so far, I think I'm able to at least.
I think if I've not gotten it wrong just now, you just explained the process of how a reviewer is going to look at the code, right?
Yep.
But means from our side, we should understand mainly first about the pull request, right? How we should submit and
Yep.
give a one line description about the issue that we are solving and
Yep.
mark the issue with a pawn symbol if I'm not wrong, right?
Yep, that's correct. Usually,
Yeah.
what you want to do is that before you if you work in an open source project, so not within the super type team. Within the super type team, you can ask in Slack, hey, can I work on this? Is this useful and stuff? But in a big project, you probably don't have access to that. So what is a good way to start in an open source project is that I always create an issue first. So I go in there and create an issue. I click on issues. Again, this is a public open source project anyway. You go and click on new issue, and then you describe the issue. You say that when I run this package on a large email dataset, I run into this error, and then you describe that. And then you say at the end of that, you said, would this be an interesting issue to solve? And and if the guys, the maintainers actually say yes, this is a cool issue, could you take a look at it? Then you can click on this assign this, and you can assign that to yourself. So click on assign yourself, it assigns to you, and then people are knowing that, okay, you're going to solve on this, you're going to work on this issue. And when you submit your pull request, you can then reference the issue number, the ID here. So that will give you an ID, and you can just reference that ID. Then people can read about all the details in here, and then click on it, and they're like, okay, so what's happening in here, and this is what's happening and stuff, and they can they get to sort of have a point of reference about what are you doing with this new code. So that's kind of the workflow. But let me talk about what to test and how to think about what kind of test is good and what kind of test is not useful. So there are a few general rules of thumb. The first thing is to always check your coverage. So here, if you go through this whole document, I think a good way is to just don't worry about the test first. Just run through this whole thing, run it step by step. Open up Jupyter Notebook or Google Colab or Visual Studio Code and run through it top to bottom. Use your own email. Use your own mailbox if you want to. So go into Google Takeout Service and then export a mailbox and do your own mailbox. But just run it top to bottom to understand at least what's happening here. What's gonna what are the main key features of the package before you even start to write tasks. So that's kind of what I would do. As a new recruit is I would do that first. So I wouldn't worry about the test. I wouldn't worry about the coverage. I would just worry about whether do I understand what each of these things are doing and what are the significance of that. What is the point of that? For example, email network, email header analysis. What's the point of that? Very commonly, this is used in trying to do something like malware detection. I think a lot of you learn machine learning and you learn about like how to classify spam from non-spam. So
how to what?
Classify spam from non-spam.
Yes.
Yeah. So in the real world, how to classify spam and non-spam, we don't just look at the body of the text, we look at the header itself. So you can see this is every email contains a ton of header. So if you look into your email, each email contains a ton of all this metadata. Same thing for your images. If you open up an image and you send me an image, and you don't know what you're doing, you're going to send an image to WhatsApp or something, I could see where you take the image from, what kind of phone you're using, I could see the timestamp, all of that are metadata. So before you want to upload your image and stuff, if you're super privacy focused, very concerned with that, you can just strip away all that metadata before you send it. But most people don't know how to do that. Most people just put it on Instagram and stuff. So so cybersecurity or hackers or whatever, they could very quickly go through an image that they find that you uploaded somewhere on Facebook or somewhere, and they could easily see a ton of information that you didn't even know was there. So these are metadata. Same thing for email. So there's a ton of things in here. So email research, like security researchers would use those to sort of understand how to build a proper spam classifier or to look at phishing attacks. I don't know if you've heard of phishing attack. Phishing attacks.
With the email, right?
Yeah, email. So they try to pretend to be somebody that they're not. So all of this stuff are in here. So try to run that and try to understand. Okay, this is what it's doing. Okay, cool. Then once you understand that, then look at the PyTest, right? Now PyTest itself, when you run the test, you're testing that all the features work. But how do you know if something is useful? So first rule of thumb, make sure that you're actually doing something to coverage. So here it says that there are 39 statements, you're missing one statement. If you fix this one statement, you will add the coverage from 97% to 100%. So what you want to aim for is to go to as high to 100% as possible. And it gives you a very detailed background of like what is missing. So it says, for example, in header, it's not very well tested. You've written 39, but you're missing 30. So you're only getting 23%. So you're getting all of this coverage. So every time you run a PyTest, you open up PyTest and you do PyTest -- COV. COV stands for coverage. And you should get a summary like that in your terminal right away. You can see, what is my coverage. So that's the first thing. Second thing is to not test anything that you did not write. So for example, people like to, for example, we do something like import numpy, SMP, and then you do something like, okay, so I'm going to create a numpy array. So this is my np and the array, and I can have my numpy array 3, 4, 8, but it turns out, right, I have a feature, and that is, let's say, x dot, let's say we check that, let's say we check that the last item, right, we check that this is equals to 8. Is this really useful? I would argue it's not really useful. Why? Because you didn't actually implement the last method. You actually use the last method implemented by numpy. You know what I mean? Same thing here, when you check something like len, you say that, hey, check whether the length of the array is 3. Again, I would argue it's not really useful. Why? Because in this case here, the length method wasn't something you implemented. It was something that you used from NumPy. So here, NumPy will do their own testing. You will do your own testing. So don't try to test method that you did not write, because
inbuilt methods, right? Basically.
This is not really inbuilt, but this is like a third-party functions. But also don't test inbuilt. Same thing. Like also don't test inbuilt Python functions, but also don't test external third-party functions. If you didn't write that method, don't test that method. That's what I'm saying.
Okay.
Rifa, you understand why this is not useful, right?
Yeah.
Yeah, because you didn't actually implement the lang. Somebody implemented that, and the guys that implemented that, they are working, they are the one that created the NumPy, and they have their own tests. And clearly it passed their own test before it was released to you. So when you use the package, you trust that has already been done. You don't have to test. Because the thing is that if you test for something, and if it doesn't work, you have a way to modify that and make it work. Well, in this case here, unless you work with the NumPy team, you really have no way to make this work, even if it breaks. So let's say the answer is 4. Now what do? You can't do anything. You can't do anything. Let's say the answer turns out to be 4. Unless you go upstream to fix it on the upstream level, meaning you go to NumPy and fix that. So in a way, it creates this kind of it's not useful in a way that even if you test it and it's a negative test, you don't get to do anything anyway. So you want to test code that you write. So that's a second rule of thumb. So every time you see a method that we implement, so for example, let's take a look at this. Let's say the header, right? 39. Okay, so let's go into header.py, email network, header.py. So this is header. Now this is the methods that we implement. For example, we implemented build from, so maybe we should test that. We implemented histogram, so maybe we should test that, right? So if somebody call an email network and it says email network.histogram, so you say something like email network. So I'm going to just call this em, and I say em.histogram. I'm expecting to get an output. Why? Because here, the histogram actually does something. And if I take a look at the histogram, it should return this, right? So then you test for this. This makes sense because you're writing this function and you want to support this function. You want to make sure it works. And so whether you're using 3.7 or 3.8 or 3.9 or Mac or Ubuntu or Linux or Windows, it should work. And that's the reason you have that in the first place. So that is a useful test. So this is kind of the way. I mean, in a way, these are just rule of thumbs. I can think of other cases where there's an exception to the rule. But let's just talk about like rule of thumb. That's what you want to be doing. So I think, for the next few days, go ahead. I think the suggestion was pretty good about like maybe try to write your own dummy test and try to get yourself familiar with that. Real Python has a article on this unit test. I think you can. I'm not sure if it's this one, but probably this one. Probably this. Yeah, probably this is quite okay. So I think you could, if you need sort of just spend like 1 hour, just block out 1 hour of your time. Don't worry about the email network right now. Just go through this from top to bottom, the article in here, and then download your email network and just go ahead and just follow through. The ones in here already. Already also has a walkthrough that is on Google Colab. You click on that, it brings you to Google Colab, and from Google Colab you can just run the package. Run the different methods of the package, and that's another way to sort of get yourself familiar with the project. So this will open up a Google Colab.
I don't think we can run from the Google Colab. I tried it yesterday. So I downloaded an IPYNB and we can.
Yeah, I think it works. Yeah, so git clone and then do pip install